Okay, let's take a look at adding parts to a component. Um, First thing, let's figure out what we're going to be adding. We'll take a look at the test report here and pick some mullion. Okay, how about uh, mullion number 1? It has part number 3 and a part number 4. Looks like a part number 28 at the middle of the span when the horizontal spacing is greater than or equal to 48 inches at both sides. Okay, so part 3 and part 4, we'll find the parts that we need in the parts list, which should be at the end of this test report. Okay, 3 and 4. 3300A and B. Okay, and that is the metal framing. So if we go back to our part, let's see, our example mullion component, we want to add a part 3300. Okay, we can also say A. We'll select this. Now, we're using this in the context of a mullion. We have a number of different ways of associating the part to the component. Because this part, the 3300A, is a stock length type material, which is consumed based on its total length. All of these part use association types will return a length value. None of them return areas. None of them return units. They're, width, height, perimeter is a distance value. In the context of a mullion, I can tell you that this is going to be a vertical component height association. That's essentially what we're looking for. The exact calculation of the different formulas can be found in the user manual. Okay, let's see. If we do a find, let's say vertical component height. Okay, I just press Control F to find and then type in. So the vertical component height is the opening height minus the top shim space minus the bottom shim space minus the top receptor minus the bottom receptor, and it returns a length value. So that is what we want. The part orientation, we have male, female, and unitary. We'll show you on the back end. Whoops. Show you kind of what's going on the back end as this relates to the configuration of doors. So we have for the entity, we have a couple of different pieces of information. So that includes door components. Okay, so we could define various types of door components. Then we have doors. This would be like the door leaf. And then we have door frames. So the type of door frame that we have associated with the system that we're configuring this component for, it's the 3100 series frame, which is actually not the correct frame to use, but that is what's used here. The list of components, we can associate a subset of the list of components, right? So all of these components have already been defined, and they can be added to be available to the door frame. If we take a look at this example, I can show you in an elevation. If we click on the bottom row of glass, we will be able to insert a new door. We can choose a single door, right, and left hand, right hand, all of that. For the frame components, okay, the left side jamb or transom jamb, or transom mullion rather, right side transom jamb, transom mullion. So because it has a transom, we're getting the transom jamb and transom mullion. If it doesn't have a transom, we get these opposite types. Point of all this is the optional components that can be selected are all like pre-configured and associated with the door frame. These door series correspond to the types of doors that can be included with the door frame. And then here we have door selectors. Really, this is the whole point of showing you about door configurations. When a door is included in an elevation, the selectors contain the logic for how the framing system should be modified. So the horizontal perimeter head component, either a linear or angular head, is going to delete parts that have a male, a female, or a unitary orientation. And if you look at that orientations, that's every part, okay? So if we insert a door in the same vertical section, it's going to delete everything at the head, everything at the sill, intermediate horizontals from the very first one all the way up to the very last one. It's going to delete all of their parts. The left vertical component, it's going to delete the female and the male. The right vertical component, it's going to delete the male and the female. If we wanted to have this, let's say we're adding a piece of steel reinforcement that we don't want to be deleted when a door is inserted because it would be used in the door frame, then we could associate that steel with a unitary type, and the selectors would not apply to the unitary part because they only delete male and female associated parts. Another way to look at it is I normally will assign everything to unitary if it doesn't really make sense. If the component doesn't make sense in any kind of a way without the parts being included. But that ties back to your door selectors. And then finally, we can add some value to the processed length. So our 3300A part is going to be assigned the vertical component height, but if we were doing like a pressure plate on a curtain wall mullion, you might want to deduct a 1/4 inch from the vertical component height. If we were putting in steel reinforcement, we might want to deduct 6 inches. In this case, what we want is exactly the same as the vertical component height. So we'll add that part. And if you recall, we also had the 3300B, which is the female. So we'll select that. In this one, we also want the vertical component height. And we have it, and they call it female. Let's see, what does it really actually look like? Okay. So the A is male, B is female. They basically look like the same exact thing. And then we have 3305, which is a male jamb. So the female, I'm guessing here that if a door frame is made with this part, it would be compatible with this part. So if we wanted to create a 3300 series door frame where this portion of the mullion remained and this portion, the male portion, was deleted, then what we could do is we could assign this one with the female orientation. We want a quantity of 1, so if there is 1 mullion, we would not want to have 2 pieces of this material cut to the vertical component height, just 1. We don't want to modify the size, so we'll add that. Okay, and the male, it's associated with the male orientation. So looking back at the door, what we could do is change the selector just to delete the male parts, which I'm not going to do. And that's as far as we'll go with the door parts. We also saw that there was a bolt. Let's see. Here we go. Okay. So we have number 28 at the middle of the span when the horizontal spacing is greater than 48 inches at both sides. Oh, this is a kind of a tricky one, isn't it? Let's see what, I guess first we ought to take a look and see what's 28, right? 28 is 3/8 through bolt at middle of span. Okay, so let's see if we have a 3/8 inch. How about a bolt? 3/8 16 by 2 1/4. Actually, that seems like about right because it's 1 3/4 inches. Yeah, it's 1 3/4 inches face dimension, so that's going to stick out about 1/2 inch. Should be about enough to get a nut on it. You'll notice that the part uses are completely different now. So we have per component, that would use a quantity of 1 of this part for each mullion. Each time the mullion is used, 1 would be used. We could specify a custom distance on center, so like if we wanted it to be 48 inches on center, although this says, well, we won't bother navigating back to it, but it said use 1 at the center when the width is greater than 48 inches on both sides. We could do other patterns, but let's choose the per component. This is going to be a unitary thing. I assume that door frames also would need to be bolted together. Quantity is 1, and the addition to the process length, we don't want to add further to the quantity, so we'll add that part. Now, what we just did, adding this part, we don't actually know if the conditions in the drawing are going to be greater than 48 inches on either side or not. But we do know that we'll have this bolt in every case that the mullion is used. I suppose in a way that it would be beneficial. Yeah, we're going to need a nut for that bolt. Suppose it's beneficial to have the part rather than to need it and not have it. Fortunately, the cost of the bolt is relatively little. Okay, unitary quantity. Now another way to make the association and actually capture the correct intent when both daylights are greater than 48 would be to create two example mullions. One could be less than 48 daylight either side, or one could be greater than 48 daylight either side. One might include these items and the other might not. Let's see if there are any kind of washers indicated on this mullion. It's hard for me to see if there are. We'll pretend for the sake of this example that there are not. That's really all that's shown here, right? A, B, and this bolt with the nut. Okay, now let's think about how this is being used, right? If we take a look at the elevation drawing, okay, every time that we have a mullion, there are fasteners at the corners of the frame. Those fasteners, obviously, they're attaching the head member and the sill member to the opening, but their occurrence is related to the mullion. You could also say that their occurrence is related to the head and the sill, and you wouldn't be wrong, but if you consider for a second the various types of mullions that are available to the system, some of these mullions have pretty substantial steel reinforcements, some don't. If we read through the details of this product approval, we would see that this mullion is not as strong as this mullion. And this mullion is going to require fewer tapcons, fewer fasteners before it fails than this. So if we provide more tapcons with mullion number 3, the mullion would be held, let's assume, in the elevation under load, a greater load, for longer. So as we change the type of mullion, the number and type of fasteners might also change. That's a good reason not to associate the perimeter fasteners directly with the head or the sill. Another reason is because you have a head and a sill, right? Let's see if we could get back to that elevation. When you think about, the time and effort required to configure a system, why would you want to put 8 tapcons on 2 different components when you can put 8 tapcons on 1 component? So if we have a look at the different parts that have been added, that's roughly what we need. We'll add a tapcon. In this case, we'll go with the hex washer head, because I expect that is what we're going to have shown with the system. Okay, they show a flathead, so we'll go with the flathead. And this is going to be required per each of the mullions. Maybe we have 8 on the male side, and we can add again eight on the female side. This way, when we include a door frame, we'll have the correct number of fasteners for the side light. And then let's take a look at adding, let's take a quick look at actually using this in an elevation. Okay, so we have the example mullion. There's still no parts, right? When you start drawing the elevation, it gets all the data that describes the mullion and includes that in the drawing. When we save it, however, it's going to look at what is actually configured, and then it's going to generate the parts list accordingly. So if we go ahead and save that, now when we start drawing it again, just open it up here. If we click on this, it's going to include the parts that we just created. If we look here, it's going to include the list of parts that we just configured for this. So let's see, my 8 Tapcons. So I have 8 Tapcons times 2 instances of 8. Both of them are at mullion, which is column 2. And that's column 2. We have 2 distinct groups of parts, each having 8 pieces. There you go. Now, we also, we can edit the part, right? And that basically takes us back to the same thing. Let me mention here, we go to edit this part. See the labor notes? There can be recommended labor amounts to add to the part. So we have a minute and a half of fabrication labor and 2 minutes per Tapcon of storefront frame installation labor. So we can add labor, and the type is going to be, we have field labor, field. You can see the slashes. This is the highest level, sub-level, sub-sub-level. So we have manufacturing, and then we have somewhere in here, somewhere, fabricate material, 1.5 minutes per part. So when this mullion is used, it's going to require 8 Tapcons for the male side of it. Each of those 8 Tapcons is going to require 1.5 minutes each for the fasteners. That's going to create 12 minutes of fabrication labor required. But we have more labor to add. The frame installation. So we have storefront, frame, install fasteners. And this was 2 minutes per part. So here we will have 16 minutes every time this is used. Now add labor, same basic story, fabricate material, and okay, we have to add a special type of labor if we want material to show up on our cut list. 2 minutes per part for cut material, and we have cut material, 2 minutes per part. Now, I would recommend as a good practice to take a look at the configuration of other systems and see what was done. So we have 7 minutes per part of frame installation as an allowance per mullion. So let's go back to our example and we'll copy that. Storefront, frame installation, allowance per mullion, 7 minutes per part. Let's find mullion 1 and see what else we can copy. Got the fastener, mullion B, aha, RG33 finger gasket. So we looked originally at the drawing of the mullion and it didn't show a finger gasket. In this case we can see somewhere in here, perhaps, it's not very clearly shown, there's a gasket in here on both sides. We also have some glass stops. The question really is, should the glass stops in the vinyl be associated with the mullion, or is it easier to make those associations with the glass component? Well, RG33, we're going to want to include that. So let's add RG33, stock length, spliceable, so that comes in a roll. That's just going to be used by the total length and it's not on a roll. Vertical component vinyl length, so that's going to add the amount per foot of the product system's vinyl, and this is going to be unitary, and we need two, one for the inside, one for the outside. So we need one inside, one outside. But we have a look at the RG33, see what do they allow on mullion 1, 0.2 minutes per linear foot. Sounds good to me. So we'll add labor. And I forgot to see, let's say, assemble frame sections, 2 minutes per linear foot. Okay. And we need a quantity of 2. So if we go back to our elevation and we save this again, and then we go back to our parts list and we refresh this, we're going to find RG33, and it looks like it's used at the jam as well as at our mullion. That was the vertical component height plus the extra 1/8 of an inch per foot, and you can see this is the difference. It's an extra inch and change. That's a fair demonstration of what is required there. Let's take a look at how the glass stops were done. We have a type A glazing gasket, so glass perimeter vinyl. That relies on the glass length. Let's see. Okay. Sum of horizontal and vertical vinyl. Doesn't really say anything about modifying that by the system's add to processed length for vinyl. But you can go through and see standard glass stops. We're deducting a 1/16 of an inch and daylight height, daylight width, I'm guessing is going to be associated with head, so intermediate horizontal. Doesn't look like it.